So this is 2019 paper 1 question 2. Okay, so we'll start off there by reading the question. So the complex number z1 is equal to 2 plus I, where I squared is equal to -1, as shown in the Argand diagram. So 2 plus 1. So 2 plus 1. Okay. Z2 is equal to 2 times Z1. Find the value of Z2 and plot and label it on the Argand diagram. So Z2 will be equal to 2 times Z1, and Z1 was 2 plus I. Okay, so Z2 will be equal to 2 times 2 is 4, 2 times I is 2I. So we can plot that there on the Argand diagram. Come across 4 and go up 2. So I can plot that there and I can label that Z2. Okay, so the second part of this question, it says the conjugate of Z1 is the complex conjugate of Z1. Okay, write down the value of Z1, the conjugate of Z1, and plot and label it on the Argand diagram. Okay, so in order to do that, what we need to do is we need to take Z1, which was 2 plus I. Okay, 2 plus I, we can see that there. And if we're going to get the conjugate of it, all that means is that we change the imaginary part from a positive to a negative. So we just change the sign of the imaginary part. So in this case, that used to be 2 plus I, and now it's going to change to 2 minus I. Okay. And again, we need to plot that on the Argand diagram. So we go across 2 on our reals, and we come down 1 on our imaginary, because negative I just means -1I. So this here would be the conjugate of Z1. And this here on the marking scheme, if you had got the two of those parts correct, you would have got 10 marks. So we look there at part 3. So part 3 says investigate if the modulus of Z2 is equal to the modulus of Z1 plus the conjugate of Z1. Okay, so I just want to develop an understanding of what's going on there. So if you just look at the Argand diagram, the modulus of Z2, so what that actually means, okay, and you should know this from coordinate geometry. So it's the length of the line Z2, right? But what they're actually checking there is the length from 0, 0 to Z2. So what they want to find there is the length from 0, 0 to Z2. Okay, so they want to know what the length of that is. And they want to know, is that equal to the length of Z1 plus the length of the conjugate of Z1, which is this length here. So they want to know if the red length is the same as the two green lengths added together, which we'll have to investigate, right? So in order to investigate that, I'm just quickly going to show you where this formula comes from. So we could start, if you just look at the red triangle first, or the big triangle there. So if you're looking for the modulus of Z2, okay, so if you're looking for the modulus of Z2, we'll take that triangle, which is a right angle triangle. We're looking for the modulus of Z2, okay, which basically just means the length of Z2. It's 4 units long at the bottom and it's 2 units high, okay. So if we're looking for the modulus of Z2, what we're effectively doing is we're going to use Pythagoras Theorem. So if you're using Pythagoras Theorem, it's the hypotenuse squared. So the length of Z2 all to be squared will be equal to the other two sides squared. So 4 squared plus 2 squared. So that will tell us that the length of Z2 will be equal to the square root of 4 squared plus 2 squared. Okay, so typically when you get the modulus of a complex number, what you would do is you'd say that the length of this is equal to the square root of this squared plus this squared, okay? So typically the modulus is the square root of the other two sides squared, okay? But we should be able to work that out using Pythagoras' theorem. Okay, so I'll just go on there and we'll finish that off. So it'll be equal to the square root of 16 plus 4, modulus of Z2, and the modulus of Z2 will be equal to the square root of 20. Okay, so that's the first part. So we've worked out what the modulus of Z2 is. Now we need to go away and work out the second part, which is the modulus of Z1 plus the conjugate of Z1. So we look there at this here, right? So I need to know what Z1. First thing I need to find out is what is Z1 plus the conjugate of Z1. Okay, so Z1 was 2 plus 1i. Okay, so that's what Z1 was. 2 plus 1i, or 2 plus I. Z2 was 2 minus I. So I'm going to add to that 2 minus 1i. Okay, so that will turn into 2 plus 1i plus 2 minus 1i. And we can see there the i's will cancel and I'll be left with the number 4, because 2 plus 2 is 4. So I now need to get the modulus of Z1 plus the conjugate of Z1, and the modulus of that will be equal to 4, because basically that's the length. What I'm finding there is the length of these two added together. So if the two of them are going to be equal to 4 plus 0i, then the modulus will be equal to, okay, so I can see that the modulus will be equal to 4. So I was asked to investigate, is the modulus of Z2 equal to the modulus of Z1 plus the conjugate of Z1? And the answer there is going to be no. And the reason why it's not is because the modulus of Z2, we worked that out to be equal to the square root of 20. And the square root of 20 is not equal to 4. Okay. And if you'd have gotten that much correct, this year, 2019, you would have got 5 marks for that. Okay, so part B. Part B says to show that Z1, 2 plus I, is a solution to the equation z squared minus 4z plus 5 equals 0. Okay? Now, you should know from using algebra that if it's a solution, that just means that it's a value for z. So it's a value that will satisfy this equation. So if I put this z value in, which is 2 plus I, if I put that into this equation, it should be equal to 0. Okay? So we'll do that. So we'll start there by saying that I'll just write out here z minus 4z squared minus 4z plus 5 equals 0. And what I'm going to put in there, instead of z, I'm going to put in 2 plus I. So 2 plus I, all to be squared, minus 4 times 2 plus I plus 5 equals 0. Okay? And all we're doing from here is just simple algebra, right? So 2 plus I all to be squared is the same as 2 plus I times 2 plus I. So I'm just expanding that there to get that. I'm now going to expand this. So minus 4 times 2 is going to give me minus 8. And minus 4 times plus I is minus 4i. Obviously, my plus 5 is still plus 5, so I'll put in the plus 5. And that's equal to 0. I'm now going to expand these brackets here. So if I expand those brackets there, I'll say the first term by everything in the second. So 2 times 2 plus I. And the second term, which is plus I, by everything in the second, which is 2 plus I. Minus 8 minus 4i plus 5 should be equal to 0. So I'm now going to expand this. So 2 times 2 is 4. 2 times I is plus 2I. Again, I've got I times 2, which is plus 2I. And now I've got I times I, which is plus I squared. And I've got my minus 8, minus 4I, and the plus 5. And all of that, obviously, is equal to 0. So we're just going to tidy this up a small bit more. So let's start by... so there's loads of different ways you can do this. I think the best thing to do is just tidy up what we have at the minute, right? So let's just tidy up what's there. So what we'll do is we'll collect all the similar terms. So let's collect all the numbers. So 4 minus 8 plus 5, right, will give us 1. Because 4 minus 8 gives us minus 4. Minus 4 plus 5 gives us a positive 1. Let's collect the i's. So 2i plus 2i gives us 4i. 4i take away 4i leaves us with nothing. So all we're left with there is our plus I squared equals 0. Now, at the very, very start of this question, so if you went back to part A and read the question again, or even before part A, it tells you that I squared is equal to negative 1. And that's very important in complex numbers. So I squared is equal to negative 1. That's the instructions at the very start of this question, right? So, if I squared is equal to negative 1, I can put negative 1 in instead of I. So I'm going to do that. So plus 1 plus negative 1 is equal to 0. And obviously 1 take away 1 is equal to 0. So 0 is equal to 0. So that shows the fact that that equals 0 shows that that's a solution to the set. Okay, solution to the quadratic. So that'll be that part done. And for that, we would have got 10 marks if we completed that this year. Okay.